Hey guys, AP here, and today we're going to be continuing our lightweight Java game library series because I know it's been a while since I've uploaded. I've been trying. I finally got it down. I'm going to put the code that you need to add in the description. It's not that much. It's only another function in the matrix. So it's another rotate. So instead of rotating on in the middle, in the center, you can rotate on around an axis or axes. So we have a rotate function. It works fine. I have tested it with my camera class that we're going to be creating today with a view matrix, and so now this is the only thing that's been stopping me, and also being able to accurately create the view matrix. So today we are going to be making the camera, which is going to be the view matrix. And yeah, so the first thing we do is obviously make the camera. So we're just going to create ourselves the camera class here, and it's going to be pretty simple. Class camera. So what a camera function does once it's all loaded in is it allows us to change the position and the rotation of our camera. So the first thing we need to do is we need to make two vectors, one for position and one for rotation. So we're going to say private vector 3f position and rotation, and import vector 3f. Is it not Control Shift O? Oh, name. Wait, no, it does have a name. Vector 3f cannot be resolved to it. Okay, I guess it has to be public. Or, no, it doesn't. Yeah, I did import it, though. Okay, so I guess there's a little bug there, so now that we have our vector in, we need to create ourselves a constructor, so public camera, and I'm just going to make two constructors, one without those vectors, and then one with those vectors. So, vector 3f position, and vector 3f rotation. So now that we got that, we could just, for here, we're going to say position is equal to new vector 3f 0, 0, 0. So is rotation. So I'm just going to copy that. And instead of position, we're just going to call this rotation. So here, we're going to do the same thing, except it's going to be this dot position is equal to position. Position is equal to position. And this dot rotation is equal to rotation. So now that we have our two constructors for whichever ones we want, we need to create ourselves like a couple of add position, set position, and all of those. So public void add position, and here we're gonna have a vector 3f value, and then we're just going to do position it's equal to position dot add, and then value, which is value, and then so that we got add position, we're going to do add position again, but this time it's going to be 3 values. So okay, so now we need float x, float y, and float see if I can type today. So that we have all the floats. Now we're just going to do new vector 3f. We have x, y, and z. So there we go. Now we're going to do the same for rotation. So I'm just going to copy this and going to say add rot. Sorry for the cut. I had to clear my throat. So next we're going to do add rotation. And for both of these, and instead of position, it's going to be rotation for all 4 of these. So we have the adds, now we're going to get the sets. So I know this is long-winded, but this is a camera, so we need as much movability and rotation ability as possible. So let's do set rotation, and instead of saying add or this, we're just going to say rotation is equal to value. Yeah, and we're going to say rotation is equal to new vector 3f x y z. Add semicolon. Same here. Position is equal to value, and position or new vector 3f x y z. And there we go. So now that we have all these functions, now we can get to the meat of this episode, the actual view matrix. So for the view matrix, we need to have the rotation around each of its, for each specific axes. We need the opposite position because a camera basically moves the world in the opposite direction. And we need the total rotation, which is just multiplying all the rotation axes together. So we're going to create a function right here called, we're just going to return ourselves a view matrix. Get view matrix. So with that, we need to import our matrix, our custom matrix, which is the engine.maths. And for here, we need to first of all get return. Let's say we need to get our matrices first. So the first one we need is matrix 4f rotate x, which is going to be equal to new matrix 4f dot rotate around the angle, which is going to be the x angle, which is rotation dot get x. And the axes is going to be the x-axis. So we need to do a new vector 3f 1 0 0. So now that we got that, we just need to copy this 3 times and for the y and z, and change that for each one. So instead of rotation.get x, it's get y and get z. And for the axes, it's going to be around the y for this one. And it's going to be around the z for this one. So then we can finally get the last one, which is all of them multiplied together for f rotation. And that's going to be rotate x dot mul, or multiply rotate y dot mul, and then the final one is going to be rotate z. So now that we have all these, we can get the translation matrix, which is going to be basically the opposite of position, and the opposite of a number is a negative number, or to negate the number. So we need to create a vector 3f for our negative position, so I'm just calling it neg position, and that's going to be position dot multiply, and then -1. So now that we have that, we can make this into a matrix itself. So matrix 4F translation, and it's going to be set to new matrix 4F dot, not identity, translate, and then neg position. So after all this, we can finally return, give me some white space here, finally return translation dot multiply rotation. So rotation. And that should be it for the function. So we have all these variables and we have all the rotation. It's all good. So now we need to actually feed it into our shaders so it can be rendered correctly. So go to basic shader, and like we did for the transformation and the projection matrix, we're just gonna have a view matrix for this one. And if you didn't know this, I changed this around. So instead of it being added into it separately, I just added it all together. I don't know if I mentioned that. It's been a while, but just I'm going to give you a little look at it. Not much has changed. It's just that I don't have one position. I just have, I have 3 locations. I have one location, and it goes into the shader altogether. So view matrix is equal to new matrix 4F dot identity. So just in case you don't have a camera yet, it doesn't break on itself. So identity, and here, so it needs to follow either PVT or TVP. If it doesn't work, if it breaks, then it won't work. So it has to be added in the middle of this. So view matrix dot multiply, and then add a parenthesis right here. So that should be good for that one, but we need to actually load it in. So I'm just going to, I'm actually not going to copy, I'm just going to make a new one. So public void load view matrix, and it's going to be a matrix 4F matrix. We're going to have view matrix is equal to matrix. So now that we have the shader and it can be loaded in, we actually have to load it in. So go to your renderer, which is right here, and since render has access to the shader, we can actually use the function to be put here. So void load camera, and it takes in a camera. I'm just gonna call it cam. And what we need to do is we need to do shader dot load view matrix cam dot get view matrix. So there we go. So there's that, and now we need to go to our main and actually create a camera. So what we need to do now is we need to create ourselves a camera class. So private static camera, and we're just going to call it camera, and we're just going to set it equal to the normal whatever. So import camera, import, there it is. Okay, import. So now we need to go to our update loop right here, because it needs to be updated every frame, or it'll just look the same. So right after shader.bind, actually not right after shader.bind, right after render.update. So right after render.update, we need to do camera dot, or not camera dot, we're just going to say load render dot load camera, and then we're just going to put in our camera. So when we run this, there should be no errors, but like nothing should change. There should be just a rotating cube. A rotating cube. So that's good. Nothing's broken. Still can minimize, still can resize it, still can do stuff. And so yeah, but what we can do is we can change our position, and the cube should get smaller. So if we say new vector 3f, or not even that, we can just keep that the same and then go to our update and just move it there. So right before load camera, we're going to do camera dot add position, and then actually let's just do the vector one. So add position, we need to do 0 on the x, 0 on the y, but then let's do negative 0.05. So that should make the, there's an error, never mind, there's not an error. This should make the cube go backwards. Yep, there it goes, bye cube. So we know that it is working because our camera is moving backwards and the cube is getting smaller and smaller. And so next episode we're going to be adding first person movement to the camera, and in the second or the one after the next one, we should be adding third person, so you can have a choice on whether which one you want or not. So this will be it for this tutorial. I hope you enjoyed it, and I'll see you in the next one. Oh, also, by the way, since my uploading schedule is pretty crap, I have a Discord channel now, and it's called just Coding AP, and there's we have all these things, and it's probably where I'm gonna be most of the time, or so you can yell at me if I'm not uploading, or if you have any problems, you can talk to me here, because I'm on my computer most of the time. So yeah. Anyways, I'll link the Discord down in the description, and yeah, so bye again.